So throughout the AS level statistics notes booklet, we have been looking at different parts of the statistics course, some of which also have a use with summary statistics that so far we haven't been looking at. We've just been looking at how we can find these values from our graphical calculator. However, if we are given summary statistics, we need to know how to handle this. So we're going to start off by having a look at the mean and standard deviation. We're also going to have a look at the variance in this section. So luckily, these formulas are given to us. We don't need to remember these for the standard deviation and the variance. These are on page 2 and also on page 4 in our formula booklets. So we can see here that we have different formulas for both the population and sample, standard deviation and variance here. So for the sample ones, it is the one that says above it, sample standard deviation S, which is the fourth formula down. And you can see that we've got both formulas there. And then the population one is the second formula down for the standard deviation. Again, we don't need to worry about calculating these summary statistics. We will only use this if the summary statistics are given to us. And we don't need to learn the formula because they're in the formula booklet, as well as the variance ones. So the sample variance formulas is the third one down in the formula booklet. And again, we have these two forms. And then the population variance formula, which is the top one. Now, unfortunately, for the mean, we are not given this in the formula booklet. So we do have to remember that we use this formula here to calculate the mean. But hopefully remembering from GCSE that we add the values together and divide the values by how many there are. And this symbol here, this kind of pointy E symbol, is a summation sign, a sigma, which is a summation sign. And this means that we have added the values together. So this symbol here means to add. So we're going to have a look at some examples of this. So here, when the alarm is raised at a market town's fire station, the fire engine cannot leave until at least 5 firefighters arrive at the station. The call out time, X minutes, is the time between an alarm being raised and the fire engine leaving the station. The variable X was recorded on 50 occasions, so that's how many times they measured this. The results are summarised in the data below. So we've got the sum of X being 286.5 and the sum of X minus X bar, and it tells us here that X bar is denoting the sample mean, all squared, is 45.16, and we're trying to calculate the mean and the standard deviation. So because this is only from a sample of 50, which means that this is a sample that we are looking at, not the population. It wasn't that all of them were recorded. It was just a sample of them that were recorded. So we're only looking at the sample ones. So if I just scroll up a little bit, we're looking at these two formulas here. Now, looking at the statistics that we were given, we weren't given the sum of X squared on its own. However, we were given the sum of X minus X bar squared. So that means that we're going to use this formula here. Now, actually in the formula booklet, these are the other way around. So it's actually the second one across in the formula booklet that we are going to use. So we are using the formula that in the formula booklet says the square root of 1 over n minus 1 times the sum of X minus X bar all squared. So that's the fourth line down. We're going to use that formula for our standard deviation. So then putting in the values that we know from the question, that's going to be the square root of 1 over n is 50, because we did this on 50 occasion, minus 1 times the sum of X minus X bar all squared, which is just 45.16. So I'm going to put this as it is into my calculator. So I'm going to go into the normal calculator part. square root, which is shift and then the x squared button, then a fraction, 1 over 50 minus 1, across to get out of the fraction, times 45.16, and double check that all of this is still underneath your square root sign and that you haven't come out at any point. And then when we click exit, that gives us our standard deviation, which is 0.960 to 3 significant figures. Now we also have to calculate the mean. Remember that you're not given this formula, but to remember that you add the values together, so the sum of x over n, so this is for the mean, which in this case is going to be 286.5 divided by the number of occasions, which was 50 from the question. And again, we can put this in our calculator, so 286.5 over 50, which gives us 5.73. So always make it clear which formula you are using. Always make it clear writing down what substitution you have used in your calculator and then actually put it into your calculator. This is very important because if I typed something in wrong in my calculator, I would end up with no marks if I didn't write anything down as to what I was doing with this. So having a look at another example, we have Claudia takes a sample of scores obtained by the entire year group on an exam. So because this time we have the entire year group, that suggests that this is a population. She compiled the following summary statistics. So we have an n, a sum of x, and a sum of x squared. And we're trying to find the mean and standard deviation. So if I go back to have a look at my formulas, remembering that this time I'm looking at the population, I haven't got this bit here, but if we remember that the mean, which is in this formula here, is calculated by doing the sum of x over n, so that's just that bit. Obviously this has got a squared on it, so it's meaning this actually. We can use this formula here because we've got the sum of x squared, we've got n, and we've got the sum of x. So back onto the other page. So again, write down the formula, make it clear. This time we're finding sigma. So we're looking on the second row down in our formula booklet, and we're going to be using the square root of the sum of x squared over n. In the formula booklet it's a capital N because it's the population count, minus mu squared. So I have to calculate the mu first. So I'm going to do this by using mu is the sum of x over n. Again, using the formula for the mean, it's not given to you in the formula booklet, which gives us 525 for the sum of x here, over n, which is 25. So 525 divided by 25 gives us 21. And then we can put our values into our formula here. So the standard deviation is going to be the square root of the sum of x squared, which is 14,825, divided by n, which is 25, minus the mean, which is 21, squared. And again, just type that in exactly as how it is there. So 14,825 divided by 25, across to get out of the fraction, minus 21 squared. Again, double check that all of that has come underneath the square root sign, and then when we click exit, that gives us 12.3 to 3 significant figures. So now I'd like you to pause the video and give the type 2 now you try questions a go. So hopefully you've paused the video and given the now you try questions a go. So for the first one, we've got calculate the mean and the standard deviation for the data, which is the population of a class. So because it says population in the question, I would suggest using the population formulas, which gives us those formulas there. You can see the sum of, the square root of the sum of x squared over n minus mu squared. For the mu, we've got 386 divided by 30, which gave us 12.9 to 3 significant figures. But as we are going to be using this in another formula, I also wrote down the exact value that that gave me, so that then I could use that in my formula, because otherwise it's going to give me some rounding errors because I would have rounded something that I was using in a formula later. So that ends up giving me, when I use that in my standard deviation formula, then 5,272 divided by 30 minus 193 divided by 15 all squared, and then all square rooted, which gave me 3.19 to 3 significant figures. So then, on the next question, I don't think it's clear enough that they would expect you to do one or the other. It doesn't mention population and it doesn't mention sample. Now, if it doesn't make it very clear, then you're within your right to use either one. So in this case here, yes, it says that NIAB finds the summary statistics for the distribution of her class's results, but it doesn't say in what context we're going to be using this. Are we only going to use this for NIAB's classes, or are we going to be using it for all the classes? So I have done both of them. So if you decided that this was a population standard deviation, we'd end up with 6.04 to 3 significant figures. And if you decided it was a sample, you should have got 6.20. And you can see in my calculator here, both of those being typed in. And that's quite important, that if the question isn't clear enough, usually in statistics, when we're having to do this, because we usually have sample data over population data, a lot of the time it will be sample over population. But always make sure you read it carefully, because if I just go back to question 1 for a second, we can see in this question it clearly said that this was a population, so we needed to do population. In this one here, it said entire year group, so that suggested that we use population. And if I just go back again, here it said that we only looked at 50 occasions, not all the occasions, and it even told us that the X bar meant the sample mean, so here it was asking for a sample. So just be careful with that. If it's not entirely clear, then you should be okay regardless of which one you decide to use. Thank you very much for listening.